Next topic is sample size calculations. So in sample size we have seen that the standard error of an estimator decreases as the n increases. For example, if we want to estimate the population mean of a target variable, the variance of y bar, which is the standard error, which is not, this is the variance, but under square root of that would be the standard error, is s square by n, 1 minus n over n. So as n will go up, the variance will decrease. It's important to remember that this is the variance of y bar and it is not the variance of the sample. Now obviously if n is equal to n, then this will become 1 and 1 minus 1 will become, and this whole thing will become 1, and 1 minus 1 will become 0, which means this whole thing will become 0. So when n is equal to capital N, then variance of y bar becomes 0, or y bar becomes equal to y. So that is why when you have a very large sample, the variance becomes less and less. Now, but we can't really always do n is equal to n because of resource limitations. So we have to select an optimal sample size, and for this we need to know what is the maximum error level of error that is acceptable for the estimate. So what is the maximum level of error that is acceptable for the estimate, and this is called the margin of error. So this is what this is. This is the difference between the estimate, which is theta hat, and the lower or upper bound of the confidence interval, because the actual value of theta may lie between this and the upper limit. So and what is it is of the confidence interval, that will obviously based on the confidence level that we want it to have, which is basically 1 minus alpha. So then what is the margin of error? So margin of error is going to be upper y minus theta hat. It can be lower y minus, it can also be theta hat minus lower y, but that is really the margin of error. So first of all, we have to stipulate that the margin of error cannot be more than a certain value. Okay, the margin of error cannot be more than a certain value. Once we did that, we go through a series of steps. So suppose we want to estimate the proportion of patients who have diabetes in the population, or patients with diabetes, or say any disease. So how do we do this? We can test all people, proportion of people. We can test all people and check who has diabetes, but that's going to be very expensive to do. So what we do is we take a sample from this population and test how many have diabetes. But how do we know how much? If the population has n, we want to take a small n, but how do we know how much of an n we should take? So first of all, we have to do this. First of all, we have to choose a sampling plan. Sampling plan just means we are doing SRSWR or SRSWR or some other complicated methods of doing this. But we first select a sampling plan, and then we select an estimate. What are we actually trying to estimate? So SRSWR, and then we are the estimate that we are going to use is a sample proportion. Be the estimate. So once we did that, the next thing we have to know is what do we need to be the level of precision. And what we mean by that is how accurate we want it to be. Suppose we decide that we will be happy if our estimate is correct plus minus 3%. So what that means is that if our sample proportion is 12%, then we are sure that the actual proportion of people with diabetes is between 9% and 12%. So that is what is meant by this margin of error. That if our sample will give us 12%, then as long as it is, we are happy with this kind of margin. So that's the level of precision. Now we know that we cannot guarantee it in statistics that it is going to be between 9 and 15. But what we can select based on statistics laws is that we will decide that okay, we will not meet in all, but as long as there is only 1 in 20 chance that some sample will not meet this criteria, that its sample proportion is between 9 and 15%. In statistical terms, we have stipulated that our estimate should be such that we can say with 95% confidence that our estimate has a margin of error of 3%, and that is where 1 in 20 is where we are coming up as 95%, which is basically just 5% error rate. So 95% possibility that only 5% chance that one of the sample will not have the population parameter within this range. So once a value of the margin of error is decided, then we just plug that into the equation. So the equation that connects to the required degree of precision usually contains some unknown parameter value, and a value of this somehow needs to be estimated or obtained. So margin of error is u of y, upper limit of y minus theta hat. In general form, you can write this as theta hat minus z half standard error, which is how we write the confidence interval anyways, comma theta hat plus z half standard error. So if we want a 5% margin of error, then z half standard error becomes equal to, and how do we express the standard error will depend on the parameter that we want. So the different parameters, for example proportion and mean, would have a different formula for standard error, but that is how you would proceed.